So where are we? Who are you?
Oh, we are in Politecnico di Milano in a rainy day,
In a rainy
unfortunately, but it's fun. Also with a guest. We have your dog here, I think. It's now coming also to visit us.
It's going to take a look.
Yes, please. So I'm Enrico. I am a professor here about buildings, and we can say that I'm quite interested in building physics. So that's why Professor Knapp wants to show me something. It's a surprise, but I will see what he wants to show.
Now, yeah, this is we designed this, and now I need to have expert comments to secure that our systems do work.
Okay.
And what we designed is a window ventilated metal cladding system. So we have a main wall with some metal cladding and a window being integrated.
Yeah.
And I need to see if this building physics works well. You get the colors, you get the opportunity to correct where it's necessary to think of. And we started with this general geometry floor plan section. You see the windows being positioned somewhere close to the insulation. I hope we did that well. You need to comment.
Yeah.
And then we go into details. These are 3 different materials. We have the aluminium, the wood, and the plastic version. And, I took them from the shelf, so I took them from the catalogs, and I'd like to see your say comments on the systems.
Yes, it's quite interesting because I can see that, for example, in all the 3 drawings that we have here, the producer have highlighted some points. We can see here, 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 and also here. We have gaskets that are really crucial for the air tightness, water tightness. We can talk about rain. And also, if because of air tightness, they work really good also in terms of thermal insulation, because if the air don't go from outside to inside, we are quite safe. But there are also different systems of windows. We can see that, for example, this is an open joint window, and so it's crucial because of the pressures in the different part of the cameras. So water that can finally arrive in this gap can go out straight. So it's really a good solution, because if, for example, we take the wooden one where air tightness and water tightness are only related to gasket, what happens if there is water and these are failing? Water is coming inside, and so this is the open joint is a really good solution.
Yeah.
We can also see that, for example, here we have a really good thermal line. So there is the thermal insulation of the wall that is in line with the thermal breaks of the window, and also with this special piece of insulation that I think you put because of the thermal bridge and because of air tightness and thermal control, right?
This comes by the system from the window supplier. This comes by the system of the wall, and then this interface needs to be locked. Yes. And this is where you end up with having compressive band being in position to secure.
Quite interesting.
Now, this is for sure your topic.
Yes,
this is what you love.
What I love, I work with this almost every day, and I see there are 3 different levels. One is related to water, one is related to the thermal control, and one is related to the vapor control. So this is crucial because, for example, in this way we can avoid any problem with condensation, especially if there is a good also thermal line. And at the same time, we can say that all the 3 barriers should work really well, because if only one doesn't work, we failed. So it's not that we have 2 and so we are safe because we have 2 and 3, but we need all 3 working in the proper
We see them
way.
in the details later. Happy to see.
Yeah.
So this is vertical, this is horizontal section.
Yes.
You see that this finds its position. And now I'm digging into the details itself. No, first, tolerances.
The tolerances that are really important, because if you have these gaps too big or too small, it's not possible to have a proper barrier related to thermal, to air tightness, and also water.
Which means if this is more than the 3 centimeter, I may have a gap, and I'm
a
not
gap,
able to
and
tape
it's
it.
not able to tape it because tape is not made for 3 or 4 centimeter gap. It's made for 1.5, 2 centimeters gap.
Yeah. Okay.
So if you have something that it's more, it doesn't work well.
Right, now the details. Line of defenses in such a detail. Did it work well?
Yeah, we can see, for example, the thermal one is really well done. So thermal break here, thermal insulation here, and this is another thermal insulation piece that can work really well. What about water tightness? If we consider that this work only with 2 gaskets, if these 2 gaskets are fine, are well maintained also, because in time gaskets can work not properly, so we have to control periodically if they are good or not good. The critical point can be here, for example, because here you have a metal sheet that it's correct, it goes under the frame of the windows, so in this case water coming here can go away and not inside. But we should consider also what happened on the side, because sometimes it's easy to work on the vertical, but we should also...
This is how I envisioned it. So we have that, say, drainage here, but we also have the window sill getting below the metal setting, which means it's somehow supposed to be actually like this. So that's getting at the back.
So this is the right sides and right also shape of this metal sheet. And if you go back to the other detail, I see that also here it's really interesting because the metal sheet is going on vertical, and it's also good because here you can have dust, and when it rains, if you don't have this, all the dust can go on the facade and mark.
Yes, marks.
So this is really well done.
Okay, thank you. Okay, this is say the vertical one. Now we go to the horizontal one. This is where I need to fix the window with these brackets, 2 screws, 1 screw from the aluminium system, and now I need to seal that whole thing.
Yeah, for thermal we are quite fine, except that I can see anything between this metal sheet and the window frame. So here
you actually would like to get some...
to add some tape that can be compressed and also fill the gap. And this is also good to control in case the vapor migration from inside to the outside, because this is our vapor barrier. But what happened here if I don't have...
If dew point is too low...
It is too low and this is not working properly, I can have condensation here.
So that's why I need to insulate. And we have this sealant as an important position.
Yeah.
Okay.
This sealant, and then we should also consider what happened here. Because this I can see it's a metal sheet, and here you have this tape that goes on the frame, metal, and then you have this.
And then there's this L-shape bar fixed to the aluminium system, which then covers that one. So I envision the window is brought in position, then I tape it, then I close it with insulation, and then I close it with...
So this is something that goes here, fixed here.
Fixes there.
Consider that if you fix, then you have some points where your vapor barrier is with a hole.
True, but then the inner aluminium system closes.
Yes.
Yeah, that's necessary. Okay. Now we go to the top part. It's the same detail, same system, same kind of sealant.
Yeah, I can see, for example, here also we have always this that is a good sealant. But also here we don't have anything, so we should introduce something.
We need to insulate here, and we need to add this one here.
Yes.
Makes sense. Right. This is the metal aluminium setting, and now we did the same in brick.
Brick, yeah.
With the brick detail, it's the same aluminium piece, same gasket, same fixing.
Yeah, same as before. Here we have good thermal. You can see that everything is working in a proper way. We have 1, 2, one sealant outside, one inside, and it's fine. Also here we miss this. Yeah.
But it's,
yeah, you're right. You're right.
And we have also to control the size of this, because we have in this drawing, we can see that there is a sealant like this. But the dimension of the ceiling is they're not the proper one, so I think it's better to introduce a specific element and then do a ceiling, so it works with the right proportion between.
So we have, say, the inner, the aluminium, we have the bricks, and then this silicon with a different dimension, and then the rope at the back to secure that it doesn't get too deep into.
Too deep in.
Yeah, that's correct. That's according.
In this way, it works well.
Yeah, yeah. This is you're right. This is according to the system, so this needs to be addressed in this detail. Right, and now we go for the final version, which is the plaster version.
Yes.
Which ends up in this kind of detail. So we have a final layer of plaster. We have a solid foam to be positioned. And when I think about it, fixing the gasket and then adding the foam, that's actually the way we need to do it.
Yes, but here we are in a different situation. We have seen that, for example, here now there is a really thin plaster. And if we consider what we told at the beginning, that this, for example, metal sheet should then go under the...
Right, I need to go here. I need to go there.
Also because it's quite important. Also, the question is, where do you stop it? Because it can be behind this, but then you can finish the metal with the plaster because it doesn't stay. And so sometimes it depends. We stop the finishing with the plaster in the front side, and then we work also here with metal.
I see. So alternative piece of metal here.
That can make it easy to
adjust. Yeah, you're right. That may help.
If we consider instead the thermal, also here we are really in a good situation. About the ceiling, the vapor barrier, we are also in the previous one, so we have also here to put this.
Yeah, and then sealant to happen here.
Sealant to happen here, and also then here.
Yeah, and then the fixing of the sealant. Yeah.
Then there is another point that we can discuss about. It's about how this window is fixed to this structure.
Right now we have these brackets, three of them. So by that, the window itself is fixed to the main system.
Yeah. But any screw, for example?
Yeah, there's a bracket, the screws here, and then there's a screw here.
Yes.
At the back side, so behind the thermal brake.
Because we have also to consider that in some points there are these screws that can break, interrupt the vapor barrier.
I see. So this is a dangerous situation. So that the screw doesn't break my vapor.
Yes, should be controlled.
Yeah.
Also this.
I get your point. Thank you.
You're welcome. It's a pleasure.
Thanks.